Hello, and welcome back to API Can Code's second unit, Computational Foundations of Data Science. In this lesson, 2.3, What is the role of programming in data science? We'll start to look at EduBlocks, which is our main programming tool for the second unit and beyond, and how students can use it to go through data and do certain manipulations with it. We recommend looking at lesson 2.R as well. Some classes may benefit from having 2.R, which is a review lesson covering some fundamentals of EduBlocks. Some classes may benefit from doing that before this lesson. Others may benefit from doing it after this lesson. Some classes may not need it at all, but we do want to make sure that's an available resource, especially for a class that is less familiar with coding and programming. So we recap our previous lesson 2.2, in which we investigated the OpenDataDC dataset streetlights, mostly through manual analysis and then with some programming. For our warm-up today, we want students to refresh their memory of index values and a little bit of conditional statements. So we've got two questions here asking about the index. This should be the fourth name on the list, so Delphos. And what columns would meet the condition speed is greater than or equal to 15. So to answer that, students would need to look at that speed row and see which values are at least 15. We spend a few slides introducing students to EduBlocks. The most important thing here is that students create an account. We've got instructions on that here, and sign into it so that they can save their work. It's also really important to note the clone, save. Saving actually happens automatically now in EduBlocks, but if students wind up on the old app version somehow, they will need to click that save button. At this point, as long as they're signed in and they've cloned a project, it should save automatically to their library. And the rename features. Those should be used with every program that students work with today and beyond. This will help them to keep an organized library of potentially useful code as they continue to go through the course and especially as they approach that final project. So again, really encourage students with every program that we use to clone, optionally save if they are somehow on the old app, and rename it. Chances are students will not need to use that save function, but I do want to mention it just in case. The other thing students can do is share their project. After clicking the share button in the top right, they can switch the project to public and copy the link to share it with anyone. There are a few exit tickets that require this functionality. So I would say early on in the course, make sure that students are doing this correctly. A common mistake that we've seen is that students will copy the URL in the address bar, which I think just takes you to EduBlocks in general. And that obviously won't allow you to look at what they did for their work. So make sure that they're actually hitting the share button, setting to public, copying the link, and submitting that link instead. So a few more blocks introducing to students to EduBlocks. We have these categories on the left based on function. And students can run their code using this blue run button, and this will show the output on the right of the screen. When the program is not running, you'll notice that the right side of the screen displays the program in text code instead of block code. We spend a few slides introducing students to JSON format. JSON is a structure for storing data. Syntax is comprised of pairs of keys and values. So for example, here name is the key, John is the value of that key. Same with age and 16, same with school and WLA. So you'd imagine if you had a JSON made up of multiple objects, each object would presumably have each of those keys and a value for each of those keys. The import JSON command in EduBlocks allows you to manipulate data in that JSON format. So we're going to use that import JSON block in almost every program that we do in this course. You'll also notice here the import request box, and these can be found right at the bottom of that left side in the requests blocks section. So what we have students do, first of all, we're going to look at this JSON format. It's entered directly into EduBlocks here as my string. And we do want to notice a couple things about the structure, particularly the single quotes around the entire data set, the square brackets around the list of observations, and the curly brackets around each observation. Any strings within the data set are put in double quotes. You notice that the only exception to this are numbers like 25 and 31. So we're going to have students recreate this program in a new EduBlocks program. They're going to go to app.edublocks.org, go to Python 3 under Create, New Project, make sure Blocks is selected, and hit Create. If you do have a class that's extremely Python savvy for some reason, they could, of course, do this in TextBase, but we really encourage using the box just for this curriculum. And we do want students creating this program entirely. This may lead to some syntax issues. We've presented this again, remember, single quotes around the whole data set, square brackets around the list, curly brackets around each observation, and strings and double quotes. We really want students understanding the structure and knowing all of its little intricacies. That's why we have them do this somewhat tedious task here. So now we're going to have students modify their print my JSON block to print my JSON 0. And this should print out only the Luigi observation. So you should see the text right below. We have another example of a modification you can make. You can access the keys directly for that JSON entry. You could access the values directly for that observation, or you could access just the name. And you'll notice here each of those modifications produces a slightly different printout. What we want students doing next is modifying the program below, which currently has myJSON 0 and name, to instead print out all the car names. And this is the first example where they have to clone and rename a program. So what students will do is go to the link at the bottom of this slide. This should, as long as they're signed in, they should be able to clone this program to their own library and then rename it. And what we want students doing is modifying this program to print out all the car names. This can be easily done by taking out the index. So instead of myJSON 0, just myJSON, and then instead of name, car. So we're going to have students now do some use and modify with a program. This is structured very much like a computer science lesson, somewhat more, I think, than our previous lessons. So students will be following the use, modify, create format. The first thing students will do is make sure they're logged into their EduBlocks account. They probably are at this point. They should go to this program linked in the slides, clone it, and save it to their EduBlocks account. We do want them renaming it so that they remember what it is. And again, they probably don't need to save it. It is probably auto-saving. First thing students should do is run the program and see how the data is stored. Now what they're going to do is attach the for loop, which should be below the code, to the bottom of the first chunk of code. Students will hopefully run this and see what it prints out. This should give the names of all the drivers. You can ask what the variable I is. This is a counter variable in this case, iterating the for loop a certain number of times. And how many times does the loop run? I can't remember exactly how many observations there are in this data set, but it should run that many times because there are that many I's in my JSON. And encourage students to sort of to that point where they're noticing that the number of observations is the number of times the loop runs. Now we're going to add a slightly larger chunk of code. This one is again below the program, so students can just bring it right up. And this starts with sum equals 0. Students are going to run the program. What this is an average weight function, somewhat clumsily designed by me. And so we want them to look at what each part of the program is doing. They should think about what happens to the sum variable each time the program goes through the loop. So you'll notice that the sum variable equals sum plus the observation weight that we're currently on. The counter also increases by 1. And then once we get to the end, our average is the sum, which at this point should be all the weights added together, divided by the counter, which is the number of times that the loop ran. This should print out an average weight statistic and a number. Talk with students about how this program works. This might be a little different than how they traditionally think of an average, or it might be just a little more explicit of a function definition than they're used to. So next, we're going to modify the chunk of code so that the program calculates average acceleration instead of average weight. You can actually do this, I think, with just one modification, change the weight to acceleration. Encourage students to think about what parts of the code need to change and what parts of the code can stay the same. In this case, there's a lot of parts of the code that can stay the same, and it's important that they recognize that. So we have another program for students to work with. I think it's the same data set, but they're going to do some new stuff on it. So in this case, they are going to follow a full use, modify, create. Last time they really just did a use, modify. So students are going to open this program linked in the slides, print it, and see what happens when it prints out. We want to hammer home the index value point. So the question at the bottom of this slide is, why doesn't Mario's information print out since he's the first one in the data? The answer being that the index value 1 would be the second observation in the data set, since that index does start at 0. Students are going to attach the chunk of code that starts with for I in my JSON and run the program again. This should print out. You notice there's a conditional statement within this for loop. This should print out just the daisy observation. We want students to think about what's going on with the purple for loop and what's going on with the green if statement, and then modify this code to only print out Daisy's speed value instead of her entire observation as it's doing right now. Students are going to create a new section on this program. The code should find the maximum speed value in the list of drivers and then print out the name of the driver. This is a challenging task. Some things to consider for students are how they could loop through the JSON value to find the maximum speed value. It might help to refer back to some previous things we've done, especially that average function, and see kind of how that works. And then students should use that speed value to find the driver who has it in the JSON. This is a slightly tougher task, but it can be accomplished with a conditional statement. Once you've got the speed value, you can compare each driver's speed value to that using a conditional statement. And students should also think about what should happen if there's a tie. So there might be multiple drivers with the same speed value. Probably what should happen is all of those names should print out, but students might need to think about how that needs to work. Our exit ticket for today asks about a couple fundamentals in EduBlocks. One is looking at index values. So I'll read the scenario. I'm working on a program to print out Toadette's data, then find any driver with an acceleration value of 5 and print those names as well. I know Toadette is the 7th driver and that the acceleration statistic is called acceleration. My program, though, isn't currently working. So a couple things in here. First of all, there's a screenshot of this program, but also a link to it in the slide. So if students want to go in and try the program themselves, they can. The first error, I'll go through these two. The first error is that myJSON7 doesn't exist because there are 7 observations. That means that 0, 1, 2, 3, 4, 5, 6 are the index values. So Toadette should be accessed with myJSON6. The other piece is that right now that conditional statement says if acceleration is 5, but this format, the syntax isn't quite right. You need to refer to acceleration within I, an observation in my JSON. So those are the two things that students should reference. I think there is a key in this exit ticket as well. As always, thanks for tuning in to this lesson walkthrough, and thank you for teaching the API CAN code curriculum.